everyone, welcome back to my YouTube channel. Today we are going to look at arrangement of capacitors. In my previous video, I explained what is capacitors and how you can solve problem on capacitors. So today I want to tell us how we can arrange these capacitors, series and parallel connection. Stay tuned. Parallel connection. When capacitors are arranged in parallel, the following applies. Now, this is what? C1, C2, C3. I told you that I told you that this is the shape of the capacitor. This is the shape of the capacitor. Then this C1, C2, and C3. When they are connected in parallel, okay, what is the equivalent capacitance? Equivalent capacitance, which is C, is equals to C1 plus C2 plus C3. So this is like opposite of resistors in series. So when we look at capacitors, they work in opposite. Resistors connected in series is added this way, but now capacitors are arranged in parallel is added as if it is resistors in what? Series. So don't forget that. C1 plus C2 plus C3. Looking at the charge Q1, Q2, Q3, we are asked to find the total charge across these circuits. It's going to be what? Total charge Q is equals to Q1 plus Q2 plus Q3, right? So the capacitors are arranged, they have the same potentials. Okay, the potential difference here is the same as this, is the same as this. So they all have the same what? Potential. Why do they have the same potential? Because they're all connected in what? In parallel. So in parallel connection, potential difference becomes what? The same. Don't forget that. So let's move over to series connection of capacitors. When they are connected in series means a straight line. So we have C1, C2, and C3. How do you get the equivalent capacitance? Equivalent capacitance C is what? 1 over C, but I can say 1 over C total is equals to 1 over C1 plus 1 over C2 plus 1 over C3. Okay? Now the PD, we have the PD across C1, PD across C2, and PD across C3. That means the total circuit voltage is what? Which is V is equals to V1 plus V2 plus V3. Do you understand that? So it's not the same as this because in parallel they have the same PD. But here they have to add the overall PD to get the total PD. Okay? So capacitors have the same what? Charge. The same charge flow all through because they are connected in what? Series. So let us look at these examples of series and parallel connection and also when they are combined together. Stay tuned. Please, are watching this channel for the first time, please subscribe to this channel for more educative videos. Give it a thumbs up, like, and comment. So let's go to the question. We have two capacitors, 2 microfarad, 3 microfarad, and these other ones connected in parallel, 2 microfarad, 4 microfarad, and 4 microfarad. They ask to calculate the effective or the resultant capacitance. For me to be able to solve this question, we are going to look at this diagram. These two, they are what? They are in what? In parallel. So we are going to solve these two that are in parallel first. Anything we have, it will not be in series with these ones. I hope you get that. Let me repeat myself. These two are in what? They are in parallel. We are going to solve it first. Then when we get the answer, we now solve these three together. Is that okay? So solution. Solution. We have for parallel capacitors. So what do we have? We have this and this. C total is equals to C1 plus C2. And my C1 here is 2 plus this is what? 4. So I have 6 microwatts farad. So looking at it, my diagram will change. Because here will be replaced with 6 microfarad. So I will have this diagram to be this way. Okay, so this is 2 microfarad, 3 microfarad. Now this one, 6 microfarad and 4 microfarad. What you're going to do is to solve it in series. And series connection is 1 over Ct is equals to 1 over C1 plus 1 over C2 plus 1 over C3. So 1 over C total is equals to 1 over 2 plus 1 over 3 plus 1 over 6 plus 1 over 4. Now looking at it, what do we do? I'm going to find the LCM. The LCM of this 2, 3, 6 and 4 is what? 12. So I'm going to have 1 over Ct is equals to 12. Okay? Let us divide it. 2 into 12 is going to give me 6. 6 times 1, 6 plus 3 into 12 is going to give me what? 4. 4 times 1, 4 plus this is going to give me 2. 2 times 1, 2 plus this is going to give me 3. 3 times 1, 3. Okay? So you're going to have 1 over C total is equal to, let us add them together. 6 plus 4 is 10. 10 plus 2 is 12. 12 plus 3 is 15. So we have 15 over what? 12. But because you're looking for what? C total and not inverse of it, I'm going to do cross multiply or I'll carry it up and down. So this is Ct is equals to 12 over what? 15 microfarad. But because I can reduce it to the lowest term by checking what can go. 12, what can go? 3 can go. 3 into this is going to give me what? 4. 3 into this is going to give me what? 5. So this is 4 over what? 5. So my Ct is equals to 4 over 5 microfarad, or I'll make it to be in decimal. So this is Ct is equals to 0.8 microfarad. So this is how we can get the effective capacitance of a series and parallel connection. That is when they are combined together. The first thing, don't forget, is to solve the parallel connection first. After solving it to get 6 microfarad, it will not be in series with this other one. We'll now solve them as series connection. Okay, so let's go to the next question. I have calculate the effective capacitance of 18 microfarad, 18 microfarad, 18 microfarad connected in what? In series, because they're in a straight line. So I'm going to say 1 over C total is equals to 1 over C1 plus 1 over C2 plus 1 over C3. Okay? So 1 over Ct is equals to 1 over 18 plus 1 over 18 plus 1 over 18. So let us find the LCM. Of course, the LCM is what? 18 because they are the same. I have 18. 18 into each set is going to give us 1. 1 times 1 is 1 plus 1. 1 times 1 is 1 plus 1. When you divide, it's going to give us 1. 1 times 1 is 1. So I'm going to have 3 over what? 18. Okay? So 1 over C total is equals to 3 over what? 18. Remember, I am looking for C total and not inverse of it. So C total is what? 18 over what? 3. 18 divided by 3 is going to give us 6. So the answer is 6 microfarad. The answer is 6 microfarad. Wow. So this is how we can solve capacitors arranged in series and when they are combined in also in what? In parallel. I hope you love this video. Please make sure you click the subscribe button and stay tuned in my next class. I'm going to put up an assignment on the board, so you have to solve it and drop your answer in the comment section. I hope you understand. Bye.